In the last video, we set up our robot template and the robot by setting the IP address, selecting the right robot model, setting a start pose to make sure that the robot always starts in the same configuration. And then we created the new tool TCP on the robot with our measure function, set this TCP as our default TCP, and use the get data from robot group down here to get the tool data that we then set in the tool definition group up here. In this video, we want to have a look at the Orient groups. So the groups that are responsible for moving our geometry from where we drew it in Rhino or Grasshopper to where we actually want the robot to move to. So to actually move it to the location we want the robot to do any kind of work, whether that is milling or drawing, like we have in this case. We want the robot to, of course, use this piece of paper to draw. And our curves are currently located close to the origin point in Rhino. And it's always good to actually position your geometry close to the origin point or close to some sort of known reference point, and later move it to the correct location, because that location might change. The location where we want the robot to do what we want it to do might change, and it's not very user-friendly to try and move this geometry to the correct location by hand, by dragging and sliding it to the right location. So we want to use reference points to do that. And our first reference point is the origin point in Grasshopper, so our coordinate system that is just at 0, 0, 0. And then we need a new origin where we basically move all of our geometry to. In this case, we create a new origin by getting 3 planes, and we will get these planes from the robot, and these planes will then help us define our new origin point both in its location but also in orientation. And we will then have a new origin point where all of the geometry that we have here will basically be rotated and moved to that location right here. So in order to find these 3 points, we have to reference these in the real world. And I will simply move the robot to our origin point for now. And this origin point is located in the top left of our piece of paper in this case. But depending on what you want your robot to do, this might be different for you. You might also want to change the way the Orient target plane is constructed in this group here. But in our case, this is quite easy because we simply have 3 points. One is in the top left, one is in the top right, and one is in the bottom left. So I'll move this robot to the origin point. And then I will get the data from the robot. However, before we do this, we have to set our TCP probe. The TCP probe is in our case the exact same as our normal tool TCP, but you might have a different probe than the TCP that you want the robot to use when doing any kind of work. So you might want the robot to draw on the surface, but the point that you're measuring from might be a different tool attached to the robot. In our case, this is the same. So I will make sure that our tool TCP numbers that we get from the robot are set as our TCP probe. And now that we have this, we can get the robot position, go over to the right, and here we find the actual position from our robot. So this is the position that our robot is currently at. If you want to double check this, you can go into the robot pendant, under the Move tab, set the feature to base, and here you will find your tool positions on the top right. However, you have to make sure, or you have to remember that the robot sometimes displays some values in meters, sometimes in millimeters, and in our case it displays the numbers in millimeters right here, but when we get the data from the robot, they are displayed in meters. So this is basically off by a factor of 1000, but this is expected and you don't have to worry about it. But you can check if this is the same, if these values match what is on the robot pendant. So now that we have this position from robot, we can right click, copy data only, and paste it as our new origin. We have to make sure that there's no new line in our panel in Grasshopper. And we will do this for the other 2 points as well. So I will move the robot to the top right point. Go into Grasshopper, get the robot position, go over to the right and right click on the position from robot, copy data only, and now I will paste this into the point right panel. I will do the same for the point down, the bottom left point. Move the robot, go into Grasshopper. Don't forget to get the new robot position. Copy the data on the right, and then set this as our point down. And now we have these 3 values, or these 3 planes that are located in space. And from that, this group then calculates our new Orient plane. And this is what we then use in our Orient to location group to move whatever geometry we have created in Rhino to this location. So our curve that we split up into different points and then created planes from is moved from here to that new location right here. And in this case, our origin point is rotated in the same way as the coordinate system, as our base coordinate system in Rhino is when you look at it from the top. So make sure that you don't have your whatever geometry you have in the top right quadrant right here, but we want to have it in the bottom right quadrant. So now that we've oriented this, this geometry is actually at the location we want it to be. So it's really on our piece of paper. And you can imagine if there was a rectangle right here, you could see where it is located on this piece of paper. Before we go into more into all of the settings that we need before sending something to the robot, we have an opportunity to also rotate these planes. And this might be necessary depending on your tool and your robot configuration. So this is that group right here. And for now, we can just set this to 0. So to recap, we set our new origin point, which is the top left corner of our piece of paper, by moving the robot with its probe TCP, which in our case is the same as the tip of the pencil, to 3 points. First the origin, the point on the right, and a point downwards from the origin. We moved the robot to these positions, and each time we selected the Get Robot Position button and copied whatever was set as a position from the robot. Make sure that the TCP probe is what you expect it to be. This might seem overly complicated, but trust me, there's a reason why we set the TCP probe right here. And make sure this is not connected to the TCP numbers right here. If you were to connect this, you might get the wrong values down the line after you send a program. In the next video, we will have a further look at the different ways of adding geometry to our robot program. We will have a look at retracting, and we will then send our program to the robot.